Hello, this is Mr. Best. Welcome to Chapter 5, questions 64 through 70. Question 64. The sides of each of these triangles below can be found using one of the shortcuts from Section 5.2. Try to find the missing links using your patterns. Do not use a calculator. And try to not use the calculator, but if you can't use your shortcuts, go ahead and find them any way you can. For Part A, if you think back to one of our Pythagorean triples, we have a 3, 4, 5 triangle. And so the 4 gets multiplied by, you can take each of these sides and multiply by 4. Try that again. This one gets multiplied by 4, 4 and 4, so 4 times 3 is 12. 4 times 5 is 20, and so 4 times 4 would make this side 16 inches. On Part B, you got a 45, 45, 90, because that's what's left over from 180. So therefore, this would be 4 yards on this side. And then since it's a 45, 45, 90, you take the square root of 2 times the leg, so it's 4 square roots of 2. On Part C, we have 10, 26, and we're looking for the other leg of the triangle. This one matches up, if you remember, with another Pythagorean triple, which was 5, 12, and 13. So if you notice that 13 times 2 is 26, 5 times 2 is 10, so 12 times 2 would be 24 feet. And then Part D, we're looking at a 30, 60, 90 triangle. The hypotenuse is 20, so the short leg would be 10 meters, and then the long leg is 10 square roots of 3 meters. So remember, you take the square root of 3 times the short leg to get the long leg. Question 65. Copy the diagram below onto your paper. A. Find the measures of all angles in the diagram. So we're just going to work through here and see what we can do. We have an isosceles triangle. Actually, both of them are isosceles, but since we know this is 35 degrees, then that has to be 35, and then 180 minus 70 is going to be 110. That's the triangle angle sum theorem. Then you have your vertical angles, so that makes that 110 degrees. And since that little triangle is an isosceles triangle, then we have 70 left, so we have to split it up into 2 parts again, and that makes that 35 degrees as well. Part B, make a flow chart showing that the triangles are similar. We're looking at triangle ABC and CDE, and we need to prove that those 2 triangles are similar. Well, we can see that the angles are all congruent, so therefore we know that by angle-angle similarity that is true. So what we can say is you can really pick any 2 angles you want. We'll say the measure of angle A is equal to the measure of angle D, and then we have the measure of angle B is equal to the measure of angle E. So we have these 2, and then by angle we can say that triangle, we'll go ABC is similar to triangle. If we're going to go AB, then we have to go A matches up with D, B matches up with E, and then C matches up with itself. And we know that by angle-angle similarity. Part C, Sherry and Roberta, notice their similarity statements for Part B were not the same. Sherry stated that triangle ABC is similar to triangle DEC, while Roberta maintained that triangle ABC is similar to EDC. Who is correct, or are they both correct? Explain your reasoning. Well, since we have 2 angles that are both 35 degrees, and they're isosceles, D could match up with A or could match up with B. So technically, both of them are correct. And once again, the reason is because you could just do a complete rotation with a dilation, or you could reflect it as well. So a couple different possibilities there, but because they are isosceles, you could match up D with B or D with A. Question 66. Using the triangle below, write an expression represent cosine of 52 degrees, then write an expression for tangent of 52 and cosine of 38. What other ratio is equivalent to cosine of 38? So 38 is the other angle measure here because they have to add up to 90 degrees. So the first thing is we need to write cosine of 52, and that's adjacent, which would be right next to, so that's your B, over the hypotenuse of C. So C is always going to be the hypotenuse. The B and A depend on which angle you're using. Then write an expression for tangent of 52. So we'll do now tangent of 52, and that is opposite, and that's A over adjacent. So that'd be A over B. And then we want to do cosine of 38. So cosine of 38 degrees. Cosine is adjacent, so that would be A over hypotenuse, and that is C. And then it wants what other ratio is equivalent to cosine of 38? Well, let's now use 52, but we have to use that side, which is now opposite, so that would be sine. So sine of 52 degrees is equal to opposite over hypotenuse, which is still A over C, so therefore those are equivalent. So we can say that cosine of 38 degrees is equal to sine of 52 degrees. So that's that last part. What other ratio is equivalent to cosine of 38? Question 67. Hadrosaurus, a family of duck-billed, plant-eating dinosaurs, were large creatures with thick, strong tails. It had recently been determined that Hadrosaurus probably originated in North America. Scientists in Alaska recently found a Hadrosaurus footprint like the one at the right and measured 14 inches across. It is believed that the footprint was created by a young dinosaur that was approximately 27 feet long. Adult Hadrosauruses have been known to be 40 feet long. How wide would you expect a footprint of an adult to be? Show your reasoning. All right, so just to get an idea here, if this represents the 14 across, 14 inches, we can set up a proportion because we can do that the footprint over the approximate length of the dinosaur, which would be 27 feet, is equal to, we don't know what the adult is, so that's our unknown footprint, over the length of the adult, which is 40 feet. And then we can cross multiply and solve for the unknown. And so once I solved, we got approximately 20.74 inches for the adult footprint. Question 68, a sequence starts -3, 1, 5, 9. If you wanted to find the 50th term of the sequence, would an explicit equation or a recursive equation be more useful? So going back to sequences, an explicit equation works for finding any specific term. The problem with recursive is that you need the term before it. So if I wanted to find the 50th term, I would need the 49th term, and then the 48th term, and so on. So if we wanted to find the 50th term, the explicit equation would be more useful. So let's write an equation that represents the sequence. Let's see how it grows. Looks like we're adding 4 every time. And we'll go back to term 0, so that would be -7. So therefore we can write our sequence t of n is equal to, it's growing by 4, so that's 4n, and its term 0 is -7, so 4n minus 7. So therefore, to find the 50th term, we would say t of 50 is equal to 4 times 50 minus 7, and that would be 200 minus 7. So the 50th term would be equal to 193. And then for part D, write an explicit equation for the sequence that follows. 3, 2 2/3, 2 1/3, 2. So it looks like it's going down by 1/3 each time. You're just subtracting 1/3. So, and once again, if we go back to find term 0, we would add 1/3, so that's 3 1/3. So an explicit equation, I'll write it as a sub n on this one just to show you a different form. A sub n is equal to, so the rate of change is -1/3 n, and we're starting at 3 1/3. So there's one way to write an explicit equation. Question 69, the probability of winning $3 on the spinner at the right is equal to the chance of winning $5. Find the expected value for one spin. Is this game fair? So we have a 90-degree angle here out of 360. So if we take 360 minus 90, that'll leave us with 270. It said that the $3 and the $5 are the same. So 270 divided by 2 would be 135 in terms of the angle measure. So 90 degrees, that would be 25, 0.25. 135, to figure out what that percent would be, you just take 135 divided by the total of 360, and that's 0.375, and that will be true for both of them. And so we're trying to figure out, is the game fair and what the expected value is. Well, we're going to win $3 every 0.375 plus $5. Same thing, and then but we're going to lose 6 for every 4th, or 0.25. So what does that add up to? And that is $1.50. So is this game fair? It is not fair because the expected value is not 0. Once again, if we're looking for a fair game, we want that expected value to be 0. But it is in favor of whoever's playing to win money, though, that's for sure. But in terms of fair, though, it is not fair. And once again, explaining that the expected value is not 0. Question 70. Janisha has a shape bucket with a trapezoid, right triangle, scaling triangle, parallelogram, square, rhombus, pentagon, and kite. If she reaches in the bucket and randomly selects a shape, find the probability at least one pair of parallel sides. All right, try to draw the shapes out so we could get a look at what we're trying to see here. So at least one pair of parallel sides. So a trapezoid has at least one pair. Right triangle doesn't. Scaling doesn't. Rectangle does. Rhombus does. It's not a regular pentagon, so it doesn't have to have those parallel sides, and a kite doesn't. So it looks like we have, I just realized I missed the parallelogram, so there adds a 4th one. So it looks like, now that I have it figured out, 4 out of 8. And as I said, I missed the parallelogram up there. So on B, what is the probability of drawing out a hexagon? Well, there's only one hexagon up here. All the other ones are 4 or 3 sides, it looks like. So for that one, that's 1 out of 8. Oh wait, a hexagon. Why can't I read? We have a pentagon. I gotta do better. So there is no hexagons. It's 6-sided, so 0. There's 0 probability for that. The probability of not a triangle, well, we could do this a couple different ways. We could count the triangles. 1, 2. See if I can do this one correct. There's 2. So that means 1 minus 2/8, which would be 6/8. So you could reduce that if you wanted to 3/4. So that would be not picking a triangle. The probability has at least 3 sides. So at least 3 sides. And I think everything up here has 3 sides or more, and it says at least, so all of them, which would be 8 out of 8 or 1, which means there's a 100% chance of getting something that has at least 3 sides.